All right, good evening, everyone. Welcome to the live chat. I want to wish everyone a happy Hanukkah, Merry Christmas. I think there's Kwanzaa. There's a couple other things going on right now. There's Yule, yeah, definitely Yule. Something that kind of like we do around here. And of course, there's Christmas, and it's just a great holiday season, and one of my favorites because I love feasts. I'm Italian. I grew up with feasts, so I'm always all about learning all sorts of different holidays because that means I get to try different food, which is always fun. Uh, but boy, do we have a lot to talk about. There is an echo. Is there an echo? Huh, Do you,
Yeah.
you are you hearing okay, hon? Okay, good. Okay, so all right, we just checked, Aaron. We're not getting an echo on our end. It could be uh, on your end. But anyway, we have a lot to talk about here and a lot to go over, and a lot of moving parts going on right now. So let's dive into it. Right? Wow. So a couple of things to first touch on. First of all, for premium updates, premium members, we're gonna have normal premium updates for the end of this week through the end of this week. Then we're going to take weekend holiday updates for Saturday, Sunday, and Monday, and a return Monday evening. So that means like no videos and stuff Monday morning. Okay, so just so you guys know, let you know ahead of time. But then Tuesday morning we go back to normal, and New Year's I really don't care about New Year's, so we'll just go on a regular schedule because I've never been much to celebrate New Year's or staying up late, except for watching CNN and watching those guys go nuts. Also, if you're a Mets fan, we already got our Christmas present or Hanukkah present, whichever, which I guess would fit for both. So there we go with that. And also, Yankee fans, congratulations on getting Judge. And Philly fans, well, you guys did a great job with your offseason as well. So I'm really looking forward to baseball this year because it's going to be loaded. Yankees, Mets, Phillies, the Braves. It's going to be great. And of course, we got football. So, and the Jets, well, they're going to be dealing with not only having to fight to get into the playoffs, but also a rainstorm and a windstorm. So, a lot to talk about tonight. As you can tell, I'm kind of excited about it. So, let's dive in and take a look at the data. Now, last week at this time, everyone was clamoring about the fact of a potential major winter storm. And as we all know, that potential basically died officially. It was dying during last weekend, and it died officially Sunday evening when we got the sampling of the shortwave, which is this feature right here, and the timing of that shortwave. Now, when we take a look at the surface map right now, all the ingredients are there. Almost all of them. You have the high latitude blocking, you have the moisture, you have the subtropical shortwave, you have the polar Arctic shortwave. Almost everything's lined up there, except for a little bit of timing. Just a little bit. How little? 3 hours. Literally 3 hours difference would be the difference between this being a major potential blizzard on the East Coast to this instead being a major blizzard in the Midwest and Great Lakes. And it's all because of the timing between these two low pressure systems and this short wave and this short wave. And the reason why I want to walk you through is because it's important for next week. When we take a look at the winds and the profile here, here's our surface low pressure system out here. This is the short wave in the subtropical jet stream that is enhancing that low pressure system. And here is our polar and Arctic short wave. The difference between these two in timing, if this short wave was a little bit slower or this short wave was a little bit faster, then what would happen would be that this short wave would capture this short wave and all that Arctic air would cascade down towards that low pressure system, create bombogenesis with an intense thermal gradient, and then boom, there's your winter storm for the northern Atlantic a day before Christmas or 2 days. That's not going to happen though. And it's not because of the blocking. It's not because the 500 millibar pattern doesn't support that potential. It's because this ridge axis is a little bit too slow. which means it doesn't have a chance to build in towards the west coast, which means that this short wave can't be fast enough, and this short wave races out ahead of it. And that is why we saw such a shift in the model guidance. Not because the forecast was completely different, or the 500 millibar pound was completely different. It's literally the difference of 3, maybe 4 hours. And when you understand that, then you'll understand why it is never, ever a good idea to discuss snow maps, snowfall potential, or say with confidence that a storm is going to happen beyond 5 days. Because stuff like this can happen. And we talked about this in the winter forecast. That there's going to be a lot of storms, rumors of storms, of potential impacts. And boy, is this ever a harsh, debilitating lesson in that for a lot of people who follow the models and don't look at the weather pattern. Now, the reason why I was personally saying, okay, I want to wait till Sunday evening to really put a nail on this, was because the disturbance that we're dealing with right here was all the way up in Siberia. Not the best sampling. So if the timing was off just a little bit in the model guidance, then you'd get basically a windshield wiper effect where the storm comes back and then you have to change your forecast again and confuse the heck out of everyone. So now we understand why we don't have this storm. Put that in the back of your mind. We'll come back to it when we look at the threat for next week. Okay? So what are we dealing with now? Well, we still have a pretty impressive storm that comes in 2 parts. The first part is dealing with our disturbance that's down here in the subtropical jet stream. And this disturbance is going to be racing towards the mid-Atlantic coast and supporting a low pressure system that's going to be tracking up the coast as this disturbance and the shortwave associated with it digs into a powerful trough and produces an impressive upper level low. So let's talk about the development of that upper level low. And I'll tell you what, let me go to 500 millibar pound first and take a look at the evolution of this feature. By tomorrow morning, there's our subtropical shortwave. There's our polar Arctic shortwave. Again, notice the separation. See, we'll even walk through this. Just a slight separation. Now, for tomorrow afternoon, we get this disturbance rounding the corner. And it's rounding the corner because this feature is digging and shifting into a negative tilt. And notice we're getting strong divergence and diffluence, rapidly rising air. And as a result, you're seeing all this strong lifting. Now, the concern with all this strong lifting, right about when the jets start to kick off here, is this jet streak here at 850 millibars. It's going to be lifting through the northern mid-Atlantic from 7 p.m. to 1 a.m. This has winds of 55 to 75, maybe even 80 knots. And what it's going to do is that it's going to rapidly drive all this deep moisture out here in the Atlantic right into the coastal plain. So you're basically going to get this fire hose of rainfall in warm air. So that's going to lead to a rapid changeover of any frozen precipitation on the coast when this initially comes in. You might see a snowflake or perhaps a little bit of sleet at the very, very, very start of this event for late tomorrow morning. But you won't even need salt for this because it's going to rapidly change over to rain. But those of you in the Poconos and Catskills where that cold air is going to hold on just a little bit longer, and let's go check that out at 850 millibars right here. This cold spot right here, and it shows up even more nicely right down here as this is lifting in. That's going to support a brief period of snow in the Poconos and Catskills, maybe about 1 to 3 inches. If you're in northeastern Pennsylvania or around the Catskills in New York, be careful tomorrow afternoon for some slick road conditions and some snow. Now, this will change over to rain because that jet streak warms up the entire atmosphere. Again, this is all out ahead of our Arctic front. So this is going to cause a rapid change over to rain. Everyone goes over to rain by 7 p.m. Everyone. So obviously it's a warm storm, driving heavy rain. You got this jet streak going here, creating havoc, and just a very nasty period of weather for tomorrow afternoon, especially as you head towards the late evening hours, right around the evening rush hour, on through the overnight periods. So that's part one, and that could be that looks like it's going to produce about 1 to 2 inches of rain, strong wind gusts. Oh, and by the way, coastal flooding is going to be a threat. Looking at anywhere between about 1 foot to 2 feet above normal as far as the wave heights, and that's going to cause some coastal flooding, minor to moderate coastal flooding. Nothing too major, all right, nothing major, but certainly some roads along the immediate coast around, let's say Monmouth County and whatnot, will likely deal with some coastal flooding. But that's the first part. Now let's talk about the next part, which is Friday morning. And I want to start off first with 500 millibars. Go to the right one here. And take a look at this feature right here. Friday morning to Friday afternoon. And we'll zoom in at 500 millibars. Now you might be wondering, why am I zooming in at 500 millibars? What we have here is rapidly falling heights. Just everything is just crashing like a rock, okay? And when you start to see this, it leads to rapid ascent in the atmosphere. Just this alone leads to rapid rising of in the atmosphere, and this alone would support an enhanced precipitation rate, right? So you have divergence and diffluence, very impressive, strong PVA with this upper level low diving into central Pennsylvania. And then as we move towards the evening, it lifts northward towards the St. Lawrence River Valley. So this process leads to rapidly falling 500 millibar heights. Meanwhile, at 700 millibars and 850 millibars, you have very strong lifting in these areas. Well, let's throw in another little piece to this. How about intense cold air transport? So here we are Friday morning, there we are Friday afternoon, and Friday evening, near historic, record-breaking 850 millibar temperatures, right? So that alone would be pretty impressive, right? Okay, let's add to this. Now you have plenty of moisture. Well, let's take a look at the surface temperatures. First, we'll look at the European take on this. We get our warm-up taking place. In fact, let me refresh this real fast and get this to load fully. So there's our warm spot, warm time period. We're in the 50s. In fact, around 3 a.m., guess what? That's your high temperature. If you want to experience your temperatures in the 50s like you would see on your weather app, you're going to have to wake up at 3 a.m. because then it starts to fall. By the time you wake up at 6, 7 a.m., you're in the 40s and 50s along the coast. Not too bad, right? 8, 9 a.m., still holding on to the 40s, but our Arctic front is starting to approach. By noon, here comes the cascade. And this is a very impressive thermal gradient. This is an impressive cold front. This is very similar to what you would experience with a cold front in the summer. But let's get to finer details, because when you're dealing with something like this, what you want to really use is some mesoscale guidance. So let's take a look at what the HRR is doing. And NAM's doing the same thing. They're literally a carbon copy of each other, which is a bit concerning, because it means that you got pretty strong agreement in the mesoscale guidance. Here you are at 9 a.m. at 850 millibars. Look what happens. You're falling by about 20 degrees in the span of 3 hours at 850 millibars. That's impressive. That is very strong frontogenesis. That's very strong lifting, very strong cooling in the atmosphere. You're rapidly cooling the atmosphere. You have an impressive thermal gradient set up, but it's not just at 850 millibars. It's at the surface. Same setup as what the European guidance was showing. But look at this gradient. This right here, you drop from the mid 40s to the lower 30s in 1 hour. After that, that gradient's heading towards the Jersey Shore. Guess what? Delaware River Valley, you're in the mid to upper 20s 2 hours later. 3 hours later, how about teens? Why is this important? Okay. What I'm seeing here in the guidance here is essentially a line of thunderstorms marching through with this Arctic cold front, and then behind it in the summer, you remember in the summer you get that line of thunderstorms, and then you get that period of moderate to heavy rainfall behind the thunderstorms. Well, okay, you have that, but instead of it being falling into the 60s and 70s, rain-cooled air, right? Instead, you're falling into the 20s and teens. And your 850 millibar temperatures are dropping 20 degrees. So the concern here is that you get this intense heavy rainfall, so your ground is wet because you just had this heavy rainfall from thunderstorms, and then your temperatures crash, and on top of that, you're having rain changing over to sleet and snow. Now, we're not talking about a lot of snow. We're talking about maybe 1 to 3 inches in the Poconos, Catskills, Mount Poconos, stuff like that. Allentown could pick up 1 or 2 inches. The coast, certainly a dusting to maybe an inch. But you're talking about a dusting to an inch on wet pavement, rapidly freezing, with strong winds around rush hour or heading into rush hour. That's going to lead to some slick, icy roadways on Friday evening as people are coming home. And oh by the way, also shopping and doing all that other stuff, right? Because the holiday season, you run to the mall, you have to get your kid that crazy toy that no one can find, but someone has found it in the mall and they're holding it for you. So you're rushing to the mall, trying to find a parking spot because no one else knows how to drive but you, and it is icy out. And you aren't prepared because you're told, hey, cold front comes through, then temperatures drop. But what they don't tell you is that the roads are going to be slick and icy, and because of the rate of temperature fall, the treatment on the road may not be enough. That is the concern here, because it's not like we're falling from the 40s into the 30s or the 40s into the 20s. We're falling from the 40s into the single digits. That is some cold air. And I'm rather concerned, given this scenario, that we might be dealing with some traffic accidents as a result. And I took a look at the skew T for this time period as the Arctic air comes in. And this is literally a thunderstorm sounding. This is your sound post sounding, right? That you would look for in the summer where, you have rapidly rising instability from the surface all the way up to 850 millibars. And then you get the goalposts, which means that as that moisture is lifting up, then it rapidly cools and you get rapid ascent, like a zipper, right? That's what you have here. This, if I saw this in the summer, we would be talking about severe thunderstorms and hail and whatnot, and rapid ascent. That's what you're dealing with. And oh, by the way, while that's happening, you have 850 millibar temperatures, winds, that are coming around anywhere between 35 and 60 knots, getting mixed down into this. So add in the strong wind gusts. So now we're opening up on Friday the potential for slick roadways, that snowfall that comes down, the initial heavy rainfall changing over to snowfall, reducing visibility below 2 miles for a short period of time. Slick roadways, like I said, some snow-covered surfaces, and also rapidly falling temperatures, and the threat for your wind gusts to cause power outages and whatnot. So you have all those factors all coming together, making for an interesting setup, to say the least. So that's the first part. Then that comes through, and we're going to be dealing with these winds setting up, producing windy conditions all the way through the holiday weekend for Hanukkah and for Christmas. And you see this alignment of the winds like this? Well, that's going to be coming off the Great Lakes, off of Lake Erie, and Lake Ontario. Let's take a look at 500 millibar PVA while that's happening. And we'll zoom out here for a second. And what you have here are little short waves rotating through under this upper level low. So this opens up, even though the models aren't showing this very well, the potential for isolated snow squalls. Better potential for the Poconos and Catskills, but really you can't really reduce that threat for the entire northern mid-Atlantic and New England with moisture coming off the Great Lakes, these little short waves picking up via gravity waves as well, enhancing these snow squalls possibly marching through the region. That's why I've been keeping scattered snow showers in the forecast for Saturday, because of the setup here that I'm seeing. On Christmas Day, on Sunday, that threat is slightly reduced, but still a potential. So I might start adding scattered snow shower warning into Sunday for Christmas as well, for those widely scattered isolated snow squall potentials. And again, that's something much like in the summer when you're forecasting a thunderstorm, where we're going to have to see that day to see if anything's evolving, but the potential is certainly there around this upper level low. So that would keep us busy enough to talk the rest of the night, right? But oh no, there's more. Because next, we got our next disturbance coming in for the middle of next week. So why am I interested in this disturbance? Well, unlike the threat that is evolving for this week, next week I already have my ridge in place. Remember what I said, I'm always looking for a ridge axis right around here. So that's already what I'm seeing showing up in the guidance. So I want to see that about 48 hours ahead of any storm development. Why? Because that allows me to amplify my trough and opens up the potential for interaction between the subtropical, polar, and Arctic jet streams all at once. That is a major clue for me, and why I kind of piqued my interest. Like, good ridge axis, good orientation. What do we need in order to set this up? Well, we have our 50-50 low, upper level low right here. So you have your blocking potential. What needs to change is the orientation of this trough and this shortwave here, and this shortwave down here. So once we get to Tuesday afternoon, what you want to see is this trough axis into a neutral to negative state to capture, to link up with this shortwave here. Slight shift, slight. So if you get that slight shift, then you get more divergence and diffluence along the mid-Atlantic coast, and a low pressure system tracking through the coastal waters with plenty of cold air to work with. The key here, much like this storm, is the timing of the short waves, except for it's an opposite evolution here. In this case, if the short waves do not evolve in timing just right, then what you end up with is a suppressed, weak low pressure system out in the Atlantic. No big deal, just a few passing snow showers. If it links up, then you get a low pressure system over the coastal waters and a significant snowfall event. We likely will not get a true idea of what we're dealing with until probably around Christmas, to be honest with you. We'll probably see a lot of non-storm or over-amplified solutions between now and Sunday. But I would say by Sunday we'll get a better idea of the timing. But it wouldn't capture my attention if it wasn't for this ridge axis here. That's key. That right there sets up your whole environment. If you don't have that, then you don't really have a storm threat. And it's something that, honestly, I should have picked up on that last week. So certainly something that I feel that I should have done better in picking up that signal, to be honest with you. But that's why you're always learning in meteorology. You're always trying to pick up, okay, what did I miss that could have made me better in forecasting for this? And that was a signal that I was concerned about. I was saying last week, hey, I would like this ridge to be a little bit further west. But it's something I really should have harped on more and jumped on more. So try to pay attention to that as we move forward. So that's our next threat. Oh, and by the way, there's more. What about the rest of the pattern? Are we warming up? Are we losing winter? Are we canceling winter? Every year, everyone's always trying to cancel winter. And every year, someone gets slapped down for this. Now, is winter canceled? No. What is happening right now? Well, our polar vortex is getting ready to strengthen. This was expected. Remember what I said. Probably somewhere around the middle of January, we'd see a relaxation. Looks like I was a little bit too slow on that idea. Instead of the second to third week, it's more like the first to second week. So what's happening right now is that we had our amplification, we had our interruption, but as I suspected, the models were too fast in causing this warm-up and seeing this warm-up. So I think it's going to be delayed. And a lot of that is dependent on the evolution of our storm for next week. If we get that storm to lock in, then that creates a high latitude blocking and one more storm after that, right around New Year's to early January, like somewhere between December 31st and January 5th, in that ballpark right there. That would be the next storm threat. But that would be dependent on what happens with this one for next week. If that locks in, it sets up the high latitude blocking for the next one. That one comes in, then the pattern ends. So that's typical of these winter patterns. You get 3 or 4 storms, and then it relaxes. So we get our relaxation somewhere around January 7th. While that's happening, we're not getting that EP flux. And so as a result, we get this relaxation. But notice, even in this relaxation on the GFS, and more so on the European, let me pull that up real fast. Well, it's not the most impressive relaxation because we're already getting signals of the polar vortex getting stretched by the time we head to New Year's. So what does this mean? Well, what this means in terms of high latitude blocking is that you get your relaxation, but then it gets re-amplification. And the synoptic models are not going to be able to catch up onto this until it actually starts happening. So what I would suspect would start to take place, let me get rid of that, is that we start to see more Pacific patterns, more Pacific air masses marching around January 7th in this evolution, but it doesn't last long, maybe a week. And then we start to see a return, and that return will be signaled by the cold air, the trough around the Aleutians, ridge building up on the west coast, trough in the east, and then return of the Arctic air after that. And what are we starting to see in the signals in our long-range pattern? Well, there's our relaxation starting to take shape. There's our trough already for our next amplification, already starting to show up on the European guidance. The GFS showing up the same thing. See your trough starting to march across North America already. And we're seeing that also in the European ensemble guidance. And let's roll forward. And as you set up, there's your trough around the Aleutians. Starting to see that ridge signal starting to pop up. Trough signal starting to pop up. There's your southeast ridge with your weakening La Nina. And also getting a slight signal of building heights around around northern Europe, which is a sign of disruption of the polar vortex on that side. The only thing you don't have around January 5th is your negative NAO pattern. So this is more like a neutral to positive NAO pattern. So what you would look for are these heights to start to shift back to the west, and the heights here around northern Europe or around Iceland to build back towards Greenland. So if I was concerned about the winter forecast, I would say I would be concerned if there was, let's say, these below normal heights taking up on the west coast, or if I was seeing this ridge axis really showing up here, or if I was seeing a huge polar vortex lock in on Greenland, then I'd be like, that's trouble. If I saw the polar vortex forecast become strong but no indication of any stretching, I'd be concerned. If I was seeing observations that were saying, hey, tropical forcing is not going to return to be supportive, I'd be concerned. But that's not happening because look at what our MJO forecast is setting up. It's moving. Here's our mild period, relative. And then we move into phase 8. Well, MJO in phase 8 is a cold wave pattern. And it's showing up on the European. It's definitely showing up in signals here as we move forward in time. There's the GFS solution, CFS solution trying to hint at it, CMT. So you're seeing all these solutions starting to hint at what's evolving here. And you're never going to get a clear, it's definitely going to do this. But you see the overall trend. So my phrase to you is this. Winter's acting like winter. I've yet to see a winter where we don't have a relaxation and thaw or whatever you want to call it. And I was expecting that, but more like around January 10th to the 20th. But it looks like it's going to be more like the 7th to 15th time period. And then we go back. We fall back into our active winter weather pattern again. So I like that idea. It looks like it's playing out really nicely. And also I am seeing the support for that from observational data and from model data. When I see this in the GFS on the EP flux, as we rotate this through, and let me see if I can get this. You see, there's our relaxation. We're not seeing much transport. And then there is our transport up. So we get this, and then we get our shift. Okay, so let me pause this for here. So this time period right here, this would support your strengthening polar vortex. That signal right there means that we're about to get interruption. And that signal right here means, hello, stretched, weakening polar vortex and a return of high latitude blocking. So everything that I'm looking at, pretty much supportive. So to wrap things up, and then we'll get to all your questions and everything, because it looks like we're pretty active tonight. We have our heavy rainfall event, strong winds tomorrow. Good luck, Jet fans, because you can't go be able to throw it, kick it. You got to run it. And it's going to be a running game, and it's going to be a mess. So good luck on that. But could be a lot of good fumbles. But I don't see how you're going to throw. Unless you throw with the wind and kick with the wind, then you could have like a field goal 80 yards out. It might be able to go through. So have fun with that. That should be interesting. Thank God the Giants and the Eagles play indoors, especially the Giants, because they might literally freeze while walking to the stadium. So that's going to be nasty. But thankfully they play indoors. And we're going to have heavy rainfall and flooding. Then we have our Arctic air mass, our Arctic blast, and we already talked about that. We could feature on Friday morning thunderstorms, flash freeze, snow, and then strong winds with the potential for power outages. So that should be fun on Friday. Christmas Eve and Christmas Day Cold, windy, watch out for snow squalls. And then we watch our next storm potential and see how that, and if that kicks off, then boom, there we go again. So, there should be a lot of questions now, huh? Let's get to it. We'll start off first with our community chat, our live chat, premium chat, and then I'll pick the best questions on YouTube here, which, wow, it looks really busy. Whew, okay. So, and keep on throwing in all your questions too. I'll get to them. And once I get to all the questions, even if we go over 9 p.m., that's fine. I got my coffee. We got good to go. So, let's go up to here. Let's see. Lots of questions. Okay. Okay, fix it. Thanks. Looking at some incredible cold air in Western Canada and Northern Rockies that is pouring south and east. Yeah. Again, if this scenario that we're seeing setting up here was cascading, and let me get... Look at this infrared satellite picture. There's a reason why I'm really impressed by this, because you have to understand the dynamics involved here. You have all this Arctic air. This is cold air. This isn't cloud cover. This is cold air. This cold air matches the cloud tops out here in Illinois. Excuse me. That's insane. That's insanely cold air. You're talking about like minus 30 degrees at the surface. And that's, we won't get that cold, but you get the idea of just how cold it is. It's so cold that the satellite cannot tell the difference between clouds and the ground if the clouds were high in the atmosphere. These are like cirrus clouds and altostratus clouds. That's the same temperature as the ground here. That's cold. Now, what really impresses me, and even when we have a miss of a storm, why I'm always impressed with meteorology and kind of get giddy about it, because you get this shortwave here, and how close this was to becoming just a monster on the East Coast, and probably really causing a problem for Santa Claus for our neck of the woods. It's so close. It's beautiful, but I can understand why it's disappointing. But you can also see the intense lifting here. So it's just impressive to see what's pouring in here. There is a big winter storm, not just for us in the Mid-Atlantic. Out in the Great Lakes and Northern Plains, they are getting hit. Yeah, they're getting crushed. And if you have any friends and family around the Great Lakes, Lake Ontario, Lake Erie, all that area, they're not getting out of this scot-free either. Because even though they missed the brunt of the synoptic scale storm, because that's going to be more towards Michigan and Wisconsin and all that, but the Arctic air that comes in is going to just create another string of monster lake effect snow bands, which we already seen what that could do to Western New York. Well, it looks like they're setting up for that again. Is there anything in particular that caused the ridge in the west to be too slow to move eastward into the western United States? It came down to primarily timing, and I tried to work my way back to the troughs, and it looks like the trough in Japan was off by about a day in timing. And if the trough was a little bit more towards the Sea of Japan while moving off of Korea and China, that would have teleconnected to the ridge being able to push inland a little bit faster, which would have teleconnected to our storm. So, blame the trough in the Sea of Japan. Good grief. NWS Chinese just sent out a tweet. Between 1:05 and 1:35, the temperature dropped from 43 to 3. That's a 40-degree drop in 30 minutes. That's what's heading towards us. Yeah, that's going to be fun on Friday. I'm probably going to do a live chat or a live coverage on Twitter and here just to cover that breakdown. And just say, okay, here's what's evolving, here's what's going on. So I'm planning on having a busy day on Friday. Looks like it's going to be interesting. Yet another fracture in Earth's magnetic field this morning. This seems to happen a lot more frequently. Well, the sun is definitely getting more active, and since I know I'm going to get that question, Let's see here. I think this is it. Oh, one of these. Oh, here we are. This is it. So our sun has been very active and continues to be active. And we have a nice two coronal holes set up here. So, yeah, it doesn't surprise me one bit. Non-weather note, Samuel L. Jackson, 74. How is that possible? He don't...
Just
Wow. I don't know. That's just insane. Any flooding concerns with this storm, both coastal and non-coastal? Yes. Minor to moderate coastal flooding will be a threat along the coast with the high tides tomorrow, with those strong easterly winds tomorrow evening and overnight. And in terms of the heavy rainfall, most likely a high threat for urban flooding because we're talking about 1 to 2 inches in a very short period of time. So yes. Will the snow and very cold air to our west northwest help keep temperatures lower than models are projecting at the moment into next week when we have more precipitation threats on the way? That's a great question. There's a variety of factors here involved here. Okay, so first of all, you have the cold air coming in. If we get any snow on the ground, that's going to feed back on that cold air. So you're going to allow your low temperatures to be lower. I think the moderation rate of our air mass is going to be slower than what's being modeled. So I kind of try to stay below a lot of the operational and kind of lean more on the ensemble guidance in that respect. But not significantly low, like not like 10 degrees off, but more like, keeping temperatures in the 30s a little bit longer. And then towards the end of the week, if we actually have that low pressure system and everything evolve, then most likely you're in the mid 30s, which I'm forecasting right now, rather than the lower 40s. So it all is kind of cumulative. So basically, if I have a mid to late morning doctor's appointment, I really need to bring 2 coats. Yes, indeed. That is definitely true on Friday. Even a coating of sleet and snow on top of flash freeze will make things hazardous. Exactly, that's my concern. Isn't it? Let's see here. Will the winds diminish on Christmas? The sustained winds will generally be closer to 10 rather than 20. I'm still concerned about the gusts mixing in from times. If we do get any of those snow squalls, that will be an enhanced potential threat as well, of gusts around 30 miles per hour or so. My concern A is the elevated thunderstorms, mixed down winds, and B, the changeover. Also, what about Saturday for snow squalls? Well, we covered all of that. Again, the snow squall thing for Saturday, we're going to have to wait until that morning to see the short waves and how they're interacting with the snow bands and see where that's setting up, and that's certainly a threat. And also, for Friday with those thunderstorms coming through, it's going to be interesting. I'm going to be fascinated by it because the line here is going to be coming in with heavy rainfall, right? Here, let me pull up this feature right here. This is fascinating to me because the line is associated with this demarcation from the 40s into the 30s. And this line here is cold enough for snow accumulation. And it only gets colder behind it. So you literally have a thunderstorm marching in with heavy rain initially, transitioning over to snow while that's occurring. And take a look at these 850 millibar temperatures in that. And this is cold enough where you start off with rain here, and then rapidly you have the support at 850 millibars for it to change over to snow at -1, which is marginal, right? So that's a snow ratio of maybe 8 to 1, 10 to 1 to get some sleet mixed in. And then it just caters after that. It just craters right after that. And this type of setup here, when you look at it, I'm not sure. I'm not sure whether the model guidance has this done correctly, perfectly, but the dynamics involved here will be fascinating. Again, not a lot of snow, but you don't need much to produce a nice little threat here for Friday afternoon. So I would not be surprised if a lot of people end up here with a nice dusting of snow on the lawns and on the roads by Friday afternoon with temperatures in the teens and falling. So we might actually end up getting our white Christmas, but not the way we wanted. So there you go. 18Z is showing some more TPV interaction. Yeah, I saw that. I want to get a little bit more data at the 0Z to see where that's heading towards. But yeah, I definitely saw that in the 18Z Euro. Let me see if I can pull that up. Let's see here. Let's see. That. And 500 millibar vorticity. 18Z. Let's see. There's our storm. And there's our setup starting to evolve here. Not bad. Not bad. Ridge evolution. This is stronger than what the 12Z. Let's see here. This is at 12Z Sunday. Yeah, this is much stronger. All right, this is just a traditional trough. And that might be a bit overdone. But wow. If that is the case, and this is already a neutral tilt right here diving in, things could get interesting. So we'll see how it plays out. Again, don't jump on details just yet. And don't be surprised if we see everything from a mist to an absolute major winter storm to a rainstorm between now and Sunday in terms of solutions. Don't trust any of them just yet. Just know that there's a storm threat. That's my word for you. If the timing to create a storm occurs, will the blocking slow it so it allows the storm to produce a significant snowfall? If you get the interaction, the blocking will set up the blocking's in place to set up that interaction. However, the question is that after the storm lifts through, does the blocking feed back on itself for the next storm following that? All I say about January warmest is the term January thaw has become well-known phrase for a good reason. Absolutely. Remember that the 1995-96 winter didn't really get the pattern locked in until mid-January. That's true. We had one good storm in December, and then it really locked in mid-January. It seems like every time forecasters say we're going to have a flash freeze in New Jersey, it doesn't happen. Am I right to be skeptical about the potential for a flash freeze this Friday or the right factors coming into play this time? Flash freezes are very difficult to pull off. The problem is, as a forecaster, is that you never want to be issuing a forecast, not issuing that threat, and then it happens. And then you get cars on the roadway not prepared, you don't have any treatment down, and you get car accidents all over the place. It's a very fine line because the issue here is that typically in a flash freeze, you have your Arctic cold front coming through. Let's say you're in the 30s and 40s and you're dropping into the teens, right? So you get a little bit of rain and then you come through with the cold air. And the dry air that comes in dries out the lower levels. No flash freeze because there's nothing to freeze because the ground is drying out with the strong winds, right? And that's a reasonable expectation. The difference here is that in this setup, if the mesoscale models are correct, is that you get this line of thunderstorms coming through and then an area of precipitation behind the thunderstorms while that cold air is coming in. So even though you have the strong winds, which would counteract the flash freeze, you also have precipitation falling while the temperatures are crashing. Even if it's only for 30 minutes, it's enough to create a serious hazard. Because as it's falling, everything's accumulating. So this is going to be a very, very tight, fine forecast. In that I hope I'm wrong. Because what I would love to see is that it changes the rain to snow, shuts down, the cold air comes in, everything dries out. That'd be great. Because then you get a little light snow on the lawns, but the roadways are okay. But that signal, let me pull that up here. This signal worries the heck out of me. Because what this is, take off the colors here. What does this look like to you? Thunderstorm line, precipitation behind it, rainfall behind it, a moderate to heavy rainfall behind it, and then you cut off. What does that look like to you? That's the summer, right? That's a summer signal here. of intense, strong thunderstorms, low-top thunderstorms marching through, moderate to heavy rainfall, and then it comes to an end, right? Well, now throw in the temperatures crashing, and you're getting that changeover from heavy rain to heavy snow and sleet, tapering off snow, temperatures falling into the teens. That's trouble, and that's why I'm more concerned than anything else. I think if I wasn't seeing this signal, then my concern for this setup would be a lot lower. Could be like, okay, it comes through, boom, here comes the Arctic front, we get some heavy precipitation, shuts off, cold air comes in, dries out, no big deal. But this signal's a little bit different. Isn't like the Jets can throw the ball anyway. Well, that's just probably true. Have family scheduled to fly into Newark on Friday around 5 or 6. How concerned should they be? The precipitation will be over, but you're still going to have turbulent winds. You might get a slight delay because of everything earlier on in the afternoon. Looking at 10 millibars on Earth News School. Okay, we'll pull that up. And let's see here. All right, let's see here. There's a strong flow of very warm air from the altitude, from the tropics up towards the poles that start near the equator, and then East Central Pacific. It seems that as if the feed continues, any strengthening of the polar vortex would be short-lived. 70 millibars still has a healthy feed from the tropics. Typically, you see this feed continuing on regardless. I understand what you're saying. To me, the key is not so much this feed, but the transport from the troposphere to the stratosphere. If we see the evolution that I think we're going to see, based on the tropical forcing that we're starting to see, then that will disrupt the polar vortex again. 250 millibars still has a cross-equatorial flow. Yes, it does. Yep. Any snow squalls from the Arctic front? Well, we already covered that. I have an appointment midday Friday. What is the timing of the flash freeze? Basically midday Friday. Instead of temperatures going from the low 90s to the mid 60s, they're going from the upper 40s to lower 50s down to the 20s. Exactly. Look at the temperature filter as the air temperature 10 millibars. All right, I mean, I understand what you're saying. I wouldn't probably look at it in the same way in this transport. I mean, I agree with you that the polar vortex, I don't think, remains strong, especially at 70 millibars for long. It's just that we're looking at two different processes. That's what I'm trying to say. But I understand what you're saying. Let me go back to the temperatures and let me check out what's going on at YouTube. Uh-oh. All right, let's see here. Why do you think the NWS and state... Okay, let me answer this. The National Weather Service offices each have their own rules when it comes to issuing watches and warnings and how they issue them. My point of view is I never tried to criticize the National Weather Service watches and warnings because I have no idea the politics that they might be dealing with. I'll put it that way. There's a reason why I didn't want to work for government. I'll put it that way. Let's see here. Let's see. All right. We talked about the back end snow. So we're going to do that. HRR is coming out. Maybe I'll give you... Okay. Well, let's see. In fact, let's see if we have the HRR guidance for 0Z out yet. Let me see. There's the European. Probably helpful if I pull. Here we are. Okay, let's reset and see. All right, let's see what we got. So there's our first wave. And again, there's our snow for northeastern Pennsylvania, probably about 1 to 3 inches. There's our heavy rainfall. Good luck, Jets. There's our heavy rain. Oof, that's going to be nasty. So tomorrow, Friday evening is just going to be, should I say tomorrow evening it's just going to be nasty out. There's our heavy rain. Then we get a little bit of break in the morning, basically between 5 a.m. and 7 a.m., you get like this nice little break between the heavy rainfall and the Arctic cold front. There's our Arctic cold front coming in. I mean, there's our setup. There's our Arctic air. Here's our front. Here's our precipitation behind it. And we'll see how that plays out as this lifts north. You could dodge a bullet in southern New Jersey. Look like the Philadelphia Metro, Central Jersey, and New York City Metro really on north gets whacked with this. Southern New Jersey, you might miss out, but again, I wouldn't put your guard down just yet. Oh, and there's the first signal of maybe one of those snow squalls popping up with all this PVA rotating around. So there's their first signal of maybe that potentially showing up. The model's trying to rendering of that potential. So a lot going on here. Do you think this could be one of those from rain to snow, back to rain? What about convection? Okay, we already talked about convection. Let's see. So a lot of good questions here. It's just I happen to answer them already. Let's see here. When do you think alerts get issued? Not sure. Probably tonight. I have friends flying into Philly tomorrow at 5 p.m. How likely will their flight be delayed? I don't think it'll be canceled, but there is a good shot for being delayed. Let's see. Next semester, I'll be starting my Earth Science class. Could you possibly give an example of how math is incorporated in forecasting? Oh boy. I mean, there's a lot. Let's see. Where would I start? Okay. So, I'll tell you what I'm going to do. Meteorological equations. There you go. Let's see which. You know what? Actually, well, you could do the hydrostatic equation, Newton's second law of motion. There's your hydrostatic equation right here. Virtual temperatures, that's all math. Let's see if I can get a better image here. This is one I actually have hung up here. One of my favorites. This is all math. Right here. This is when I'm doing a forecast, this is what I'm doing in my head every day. This whole thing right here. And this part right here, this helps me figure out the movement of air masses, geostrophic, full equation of motion. That one was always tough for me to work with. Conservation of momentum. Remember when I keep on talking about conservation of mass? When I'm always talking about that balance? Well, this is the equation that I'm talking about. Okay? Right here. This whole equation right here. So yeah, that's a part of it. The D's here, that means change. This delta, that's velocity, that's time. So yeah, there's your equation. I don't mean to scare you, but I doubt in Earth Science you'll be dealing with that in the first class. I can't see that. Shelf cloud chase time. Yeah, I could definitely see a shelf cloud out of this on Friday. Let's see here. I live in northwest Morris County. It takes longer for temps to rise. The weather is similar to Warren and Sussex County. I believe that. I keep on hearing that this will be a historic storm for some regions. Definitely for the Great Lakes. And in terms of temperatures for Christmas, it'll probably be one of the coldest winters in 30 years, if not more. Let's see here. What do you look for in a strong wind sounding to see if... Okay, so this is what I look for in a strong wind sounding if I'm looking for mixing. Because you have an unstable atmosphere, rapid rising, mixing, and then you have the strong winds here. That math looks intense. Yeah, I mean that's. I don't mean to scare you, but that's like basically what, like sophomore meteorology, and then junior and senior you get more complex. And then let's see here, you have multivariable calculus thrown in here. Yeah, I mean this is the basic stuff. I mean you should see the like the doctorates and stuff. Man, they play with this stuff all the time. But yeah, that's why we're nerds. It's stuff we deal with all the time. Let's see here. Back to the live chat here. What time tomorrow does the heavy rain start in northeast New Jersey? I'm thinking. Let's see. I was thinking more like around 4 p.m. But let me double check that since we got new data here. So it looks like it starts to come in around noon, so a little bit faster. And I'll double check that tomorrow morning just to get a better idea. But moderate to heavy rainfall comes in around noon and gets really intense right around the evening rush hour. Do you expect ocean effect snow once the front comes through? Yeah, actually, I would not be surprised. You know what? That's a great point. You have all this cold air come through. You know what? You guys on Long Island, that cold air's coming in. You have a strong northeasterly winds. You know what? If the winds align just right, you could have lake effect snow showers coming off of the Delaware Bay and off the Long Island Sound. Yeah, I mean, I wouldn't forecast any snow accumulation just yet on that, but yeah, I mean, you could technically see a snow band take off like on the Long Island Sound with a strong west-northwesterly wind coming to Suffolk County, maybe Queens, Nassau. Yeah, I can see that. And the cold air's certainly going to be cold enough. You're going to have plenty of instability. Waters are certainly warm enough in the Long Island Sound. That's a great point. That's a real good point. Good job. Yeah, I could definitely see that. Now that I really think about it. No, hold it. One second. Let me pull up. Let's see here.
I love you.
Here. Oh, yeah. Let's take a look at this. You're talking about around minus 20, minus 19 degrees Celsius coming around here. That is more than enough instability. You guys around Long Island, you might actually get some snow on Christmas Day via if everything lines up just right, you could actually get a surprise snow band coming off of the Long Island Sound. Oh man, that'd be funny. That'd be something, wouldn't it, huh, guys? That would certainly catch a lot of people by surprise. It's after 9 o'clock, so...
Well, it was almost 9 when you went over to the YouTube, so I was just like, let you go.
Oh, sorry. Well, it's been a busy night, that is for sure. I want to thank everybody for watching and oh, we got a question here. Let me see here. I haven't seen it yet. Let me refresh this and see if I can get the question to show up. All right, let me.
Most recent thing.
I see it now. How large of a body of water do you need to have lake effect snows? It varies. Usually what you want to do is about the size of Long Island Sound. You could pull it off. You can have mesoscale snow take place with like a large lake. Depending on the cold air and the fetch of the wind, sometimes you don't need a lot, okay? But I would say the minimum would be something like the Delaware Bay in terms of size, or the Long Island Sound in terms of size. But you can get like flurries taking shape. If you get like, let's say, winds coming off of like the Finger Lakes here, you can get something set up there. Those aren't huge lakes, but the combination of them can definitely be enough. So it depends on a couple of factors. The fetch of the winds coming across the lake, whether it's maximized, the instability in the atmosphere, in terms of the difference between the temperatures at the surface of the body of water and the wind and the temperatures at 850 millibars, and whether or not you have confluence or diffluence at the lower and mid levels and how that sets up. Lake effect snow and snow bands are actually a very, very small version of a warm core low. So they're almost like micro hurricane setups, micro warm core lows. Okay, so that's what's cool about them. They're really unique and impressive. And it's all driven by the warm core process as opposed to the cold core process, which is pretty cool. So you essentially have a warm core setup within a cold core environment. I know, I'm crazy. What can I say? So, I think that is everything for tonight. I think I covered pretty much everything. Going to be interesting to check out the model guidance over the next couple of days. We might have something even more to talk about. We will have our live chat again next week. Don't worry. And then we'll rock and roll on that. Again, just to reiterate, for premium members, we'll have our regular discussions and videos for tomorrow and Friday. And then from Friday evening, I'll be off unless we're dealing with something crazy. And Saturday, Sunday, and Monday are going to be weekend holiday updates. And we return to normal updates Monday night into Tuesday. So that's it. And I think, again, thank you again for watching and joining. And I will see you next week. And if I don't see you, I hope you all have a Happy Hanukkah, a Merry Christmas, and whatever else you might be celebrating around this time of year, a Happy Yule, whatever it is. I hope you have a wonderful time with you and your family. And as always, stay safe out there.